Hi everyone. Now I'm going to be going over the chapter 1 review. Again, you're not going to have a test on this right now. I mean, maybe later on and down the road you may, but for right now you will not. So I am going to switch it over so that you can see what I am talking about. So I can go over. Again, you should have at least tried it on your own. And if you haven't, you should pause it and do it on your own before you even go over these, just to see what you do know and what you don't know. And if you still need help on something, then you need to let me know and I can Zoom with you to better help you understand it. So I am going to flip this around. All right, so I told you that you didn't have to do this, and you don't, but those of you who may have already have done it, here it is just changing up the grouping, and it's of multiplication, so it is the associative of multiplication. Next, it flipped up the groupings again, which is the associative of addition, because it's all addition. This one was identity property of multiplication because it kept it the same. This one is just flipping around the order of the numbers, so that is commutative of addition. This one just flipped around the numbers too, and now it is talking about multiplication. So this is the commutative property of multiplication. And then this one was the identity property of addition because it kept it the same. So now we're going to come down here. So here is this is what it's trying to say. So sometimes it's better if you are writing it out to help you understand what it's saying. So it wants to know if you took 17 and you made it smaller by a place, would it get 170? So if you would start here and you would move it in one place, it is 100% not going to be 170. So this is a false statement. Next, this one says if you take 660 means times 10 times as much as 600. So you should have started at 600 and then moved it out one place to make it bigger, and it would have been 6,000, which this is not saying 6,000. So this is a false statement as well. Next, this one is saying 900 means equal 1/10 of 9,000. So where do you put the decimal? Here you start it at 9,000. Now it says to make it smaller by a place, and it should equal 900, and it does. So this is a true statement. Next, this one is saying 4,400 means equals 10 times as much as 440. So it starts right here, and then you make it bigger by a place, so you move it out one place, and then you would do 1, 2, 3, comma. And yes, that is what you are seeing, so this is a true statement as well. Okay, now the next one is up here at the top. It is wanting to know what are some other ways to write this, and they said mark all that apply. By the way, this is something that you could see definitely on the state test. So this is very important to note that they will write also mark all that apply. So it is very possible to have more than one answer. So let's go ahead and look at this and see if this is true. I'm going to switch over to my pencil so it's a lot easier for me to see. They're saying that this one is showing a 7 in the 100,000. So if you use that one thing that I did, put a 1 down under that digit and add zeros, that is showing 100,000. So that is true. The next one is saying the 5 is in the thousands place. And if you put a 1 under it and add zeros, that is false. It is only in the hundreds place. So this is wrong because of this part right here. Next one, they're saying, is this how you say this number? Is it showing 700,000? Yes, so far it's showing that. 562. 562. Yes, it is showing that. So B should have been one of them. Next one is saying if you pulled this out and just made it numbers, this 7 would be the 700,000, which is true. And this 5 is worth 500, which is true. And then the 6 is in the tens, so 6 tens is 60, that's true. And then the 2 is in the ones, which is 2. And so, yes, this is another true statement. Then this one is saying the 700,000s, that is true. Plus 500s, that is also true. And then the other one is saying 62 tens. Now, if it is 62 tens, that would be like 62 times 10, which is actually saying 620, which is false. So that is not correct. So the only two that were right were B and C. Next one, Carrie has 140 coins. She has 10 times as many coins as she had the last month. How many coins did she have last month? So we're actually working backwards here. So it's saying 140 points now, 140 coins now, which was 10 times last year. So they want you to find out what last year's was. So in this case, you would have to work backwards and do the opposite. So you should have done 140 instead of timesing by 10. You should have done the opposite, which is timesing by a tenth or making it smaller by one place. So you start here and you move it in one place. Your answer should have been 14 coins. Okay, next. Here it says explain the pattern of zeros in the product when multiplying by the powers of 10. So they're showing you here that 10 to the 0 power has no zeros. This one has 1 0. 10 to the second power has 2 zeros, and 10 to the third power has 3 zeros. So they wanted you to know that the exponent is going to tell you how many zeros are to be added. To the product. Okay, so that is what I want you to write on that one. Then the next one is saying it is 3,452 miles round trip. So that means there and back to Craig's house. If he travels to her house 3 times this year, how many miles did he travel in all? So it already told you what the round trip was. So there was no just one way. It told you it all. So here you should have done 3,452. And then he made this round trip 3 times. So you should have times it by 3. So then 3 times 2 is 6. 3 times 5 is 15, carrier 1. 3 times 4 is 12, plus 1 is 13, carrier 1. And then 3 times 3 is 9, plus 1 is 10. So this should have been 10,356 miles. All right, the next thing that they wanted you to do, it says Lindsay earns $33 a day to babysit for her part-time job. Sorry, her part-time job. So complete this table to show how much she's going to earn for 3 days. So in order to find 3 days worth, you would have to do what she does a day and times it by how many days she's doing it, which is 3. So this would be a 9, and 3 times 3 is 9. So then for 3 days, she would get $99. Next would be 33 times 8 now. So 8 times 3 is 24, carry your 2. 8 times 3 is 24 plus 2 is 26. So this one would be 264. Next, now they wanted to know how much she would make for 14 days. So then now it is doing 33 times 14. Now remember, there will be 2 rows of numbers. This one would be telling me 33 times just 4, and this is going to tell me 33 times not just 1, but by 10. All right, so now we can go ahead and do it. 4 times 3 is 12. Carry your 1. 4 times 3 is 12, plus 1 is 13. And then he gets caught. Bring it on down. Cross out any remainders, and then we start again. What is 1 times 3 is 3, and 1 times 3 is 3. And then you add this. 2 plus 0 is 2. 3 plus 3 is 6. And 3 plus 1 is 4. So then Lindsay would make for 14 days $462. All right, next. It says, Jackie followed these steps to evaluate the expressions. So they're telling you exactly what Jackie did. Mark looks at Jackie's work and says she made a mistake. She said that she should have divided by 3 before she subtracted. Which student is correct? So what we should do is I would personally go off to the side and do it myself and kind of follow along. So please excuse my dear Aunt Sally is going to tell us the order of operations that we have to go by in order to do this. So the first thing that we should do is we should look for parentheses. There is parentheses. And they said that she did 45. Which is correct. So far, so good. She did it right. Then is there any exponents? No, so she is correct. Then bring it on. Bring everything on down that was not used. And so now we have to look for any multiplication or division. Was there any multiplication or division? Yes, there was. So actually, that should be the next step and look at what they said that she did. She did 45 minus 15, and that is false. So therefore, which student was correct? Mark, because division comes first before subtraction. All right, now the next thing is, it says evaluate the expression. What evaluate the expression means is it means solve it. So now we have to solve this. So we're just going to come on up here and just solve it from right up here. So now it's saying, okay, so we now know that we have to divide first. So let's divide. 45 goes in the box, 3 goes over here. How many 3s go into 4? That's once. That would be 3. When you subtract, that would be a 1. Check it. We are good. Bring down your next number. How many 3s go into 15? That would be 5. 5 times 3 is 15 with nothing remaining. Our answer to this is 15. So this would be 15 minus 15. 15 minus 15 is 0. So that is your answer. The answer to this was 0. All right, now to the next. Now this was kind of difficult, and that's why I had it out, because you're not going to see anything like this right now. And so you won't have to worry about it yet. This is actually something you'll probably be seeing in like 7th grade more than anything. So here we go. It says Carmine buys 8 plates for $1 each. He also buys 4 bowls. Each bowl costs twice as much as each plate. The store is also having a sale that gives $3 off the bowls. Which numerical expression shows what he spent? So that is a lot of things to talk about here. So it says 8 plates for $1. So the things that are showing first, 8 for $1 each, is both A, B, and C. D is automatically out because of that. Now it says he buys 4 bowls. Each bowl is twice as much as a plate. So each plate costs $1. So 2 of them would be, so 2 times $1 would be $2 a piece. So he buys 4 bowls for $2 a piece. So that's the next part. Well, this is saying way too much, and so is this one. And so this one is the only one that's making sense, and then has $3 off of the bowls. So that's why there's -3. So the only one that was true here was C. Again, you're not going to see this big of a expression yet, but you will definitely see that probably in 7th grade. All right, now this one says evaluate, which means solving it. So I'm going to rewrite it over here so I can actually have enough space to solve it. And when you see something like this with lots of different numbers, lots of different operations and symbols, you have to use please excuse my dear Aunt Sally. So this is a please excuse my dear Aunt Sally question. So is there any parentheses? Yes. And so when you add these two, that would be 72, and you bring everything else down. Is there any more parentheses? No. Is there any exponents? No. Any multiplication or division? And yes, there is. So off to the side, I'm going to do 72 times 3. 3 times 2 is 6. 3 times 7 is 21. So that would be 216 plus your 2. So this is that answer. And you have plus 2 left. So that would be 218 is your answer to this. So that one would be 218. All right, next. An adult elephant eats about 300 pounds of food each day. So again, this is each day 1 elephant. Write an expression to represent the number of pounds a herd of 12 elephants would eat in 5 days. All right, so here's the thing. It said 1 elephant would eat 300 pounds a day. But how many elephants are there in these days? So how many elephants are they talking about? They're saying a herd of 12 elephants. So there's not just 1 elephant, there are 12. So you could times this by 12 to figure out the herd for 1 day. Then it says, but they want to know, so this is just 1 day's worth for the entire herd. Now they want to know, how about for 5 days? Well, then you can just say times 5 over here or times 5 over here. It does not matter. So as long as it looks something like that, that would have been fine. All right, next. Jason is solving a homework problem. Ariana buys 5 boxes of granola bars. Each box contains 12 granola bars. So Ariana eats 4 bars. Jason writes a numerical expression to represent the situation. His expression says what she should do is should take 12 granola bars minus 4 of what she ate and then times that by 5. Has a mistake. Explain Jason's mistake. So let's see what should have happened here. Ariana buys 5 boxes. So there's 5 boxes. Each box has 12 granola bars in them. Oh, so we should be timesing this by 12 because each one has 12 in it. And we're buying 5 of those boxes. Then they're subtracting 4 that she eats. So the mistake is he did 12 minus 4 first, which should have been 5 times 12 first. And then after they do that, then to subtract off 4. So then it says, so that should be the actual thing. So this one should have been done first and then subtract off 4 after you find that answer. So it says write an expression to show how many granola bars are left and then solve it. So this is our expression to find out. So I'm going to hurry up and just write that down. The first thing that you should do is you should do parentheses first, of course. So 12 times 5, 5 times 2 is 10, carry a 1. That would be 5, plus 1 is 6. So that would be 60 minus 4 is 56 bars. All right, next. This is saying Paula collected 75 stickers and she shares her stickers with 5 of her friends equally. How many stickers will each friend get? So remember, this is what our division was. We were dividing 75 and we're going to divide that evenly amongst 5 friends. So we should figure out the answer first, and then we can fill in these missing blanks here. So 5 can go into 7 one time. 1 times 5 is 5. Subtract it, that would be a 2. Then check it, you are okay. Bring down. How many 5s go into 25? That would be 5 times. 5 times 5 is 25 with nothing remaining. Your answer is 15. So to make this a true statement, it should have been 15s placed in there. All right, next. It says Mario is making dinner for 9 people. Mario buys 6 containers of soup. Each containers has 18 ounces. If everyone gets the same amount of soup, how much soup will each person get? All right, so first of all, we got to figure out how much he bought. He bought 6 containers of soup. So here's 6 containers. And then each container has 18 ounces inside of it. So you should be timesing this by 18 to figure out how much soup that is. And then they're saying that you're going to divide it amongst everybody at this dinner. So then you would have to divide it amongst 9 people. So first we have to multiply this to figure that out. So 18 times 6, 8 times 6 is 48, carry your 4. 6 times 1 is 6, plus 4 is 10. So that would be 108 ounces of food, and you're going to divide it amongst 9 people. So if you're going to do this, you would put it in a division problem. Can 9 go into 1? No. Can it go into 10? Yes, 1 time. 1 times 9 is 9. Subtract, that would be a 1. Check it, we are okay. Bring down your 8. How many 9s go into 18? That would be 2. 2 times 9 is 18. Subtract, that would be 0 remaining. So therefore, each person will get 12 ounces. All right. Now, the next part is they want to find the quotient. Use multiplication. Oh, I shouldn't have said that. Don't use the distributive property. Oh, sorry. You were supposed to find multiplication. So this is where you work backwards again. I want you to first divide it. 144 by 8. And we're going to find the answer first. Can 8 go into 1? No, it cannot. Can it go into 14? Yes, one time. That would be an 8. If you subtract it, that would be 6 remaining. Check it. It is okay. So then you bring down your next number, which is a 4. How many 8s go into 64? 8 times 8 would equal 64. So then when you subtract that, that'd be 0 remaining. So therefore your answer was 18 to make this true. Now they wanted the multiplication facts to make this a true multiplication, two multiplication facts based off of these numbers. So the first one would be working straight backwards, which is 18 times 8 equals 144. And then the second one would be just flip-flopping these two and saying 8 times 18, because we would use the commutative property of multiplication to do that, equals 144. So you had these two as answers. Next, if Jeannie eats 1,840 calories a day, how many calories will she have eaten after 182 days? Okay, so this is going to be quite a big problem. And because of it, I'm going to put that way up here where I have some space. So this is 1,840 calories, and we are going to times it by 182 days. All right, so first thing, first we're actually going to have 3 rows because there's 3 digits at the bottom row. So this one is when you times 1,840 by 2. This is when you times it by 1,840 times not just an 8, but by 80. And then this one is when you take 1,840 times not just by a 1, but by 100. So that's what the rooms are going to be. All right, so 2 times 0 is 0. 2 times 4 is 8. 2 times 8 is 16. Carry your plus 1. And then 2 times 1 is 2, plus 1 is 3. All right, so then after that, we are going to bring this down right below this. Remember, it's cut. Also, it's from that 1 0 from the back of 80. Then cross out any remainders, and then we start all over again. 8 times 0 is 0. 8 times 4 is 32, so carry your 3. 8 times 8 is 64, plus 3 is 67. Put the 7 down, carry your 6 to the next side. 8 times 1 is 8, plus 6 is 14. So there is that. But we are still not done because now there's not just one person that caught, there's now 2 people that caught. Also, where does those 2 zeros come from? It comes from the 100. So those are the 2 zeros from the 100. Then we start all over again. So then you go 1 times 0 is 0. 1 times 4 is 4. 1 times 8 is 8. And 1 times 1 is 1. Now you can go ahead and add all of it. So this would all be 0. This would be 8. This would be 8. This is 10 plus 4 is 14. Carry your 1. This is now 5 plus 8, which is 13. Carry your 1. And now this is 3. So your answer is 1, 2, 3, comma. So it would be 334,880. So I'm going to put that down here. 334,880. All right, so that is that page. And then we're on our very last page. So here we go. There are 8 teachers going to the Science Museum. If each teacher pays $15 to get inside, how much did the teachers pay? So remember, it says each teacher does 15, but how many teachers are there? There are 8, so you would times it by 8 to figure out how much the total cost for them. So 8 times 5 is 40. Put a 0 down, carry your 4. 8 times 1 is 8, plus 4 is 12. So the answer is $120 for all 8 teachers. Next, it's giving you another one of these. They want you to write all the ways possible to say this number, but it says mark all that apply. So again, it is very possible to have all of them be answers. It is possible for all 4 of them to have the right answers. So then you have to go through and check it. So very quickly, I will do that. I'm just going to grab a pencil. All right, so the first one is saying that 5 is going to be in the 10,000s. So we can check it to see if that is true. Yes, it is very much true. So that one is right so far. Then we don't have to write the 0, so that's why there is no 0. So far it's looking good. The 8 is saying it should be in the hundreds. So if you put a 1 under it and add on zeros, yes, that is saying that. Then plus, now it's saying a 9 should be in the tens place, which is true, so that is good. And then the 7 should be in the ones place, which is also true. So, yes, A is correct. So I'm going to color in A. All right, then after that, then you go on to the next one. It's saying that the 5 is worth 50,000, which is true. The 8 is worth 800. The 9 is worth 9 tens, which is 90. And then the 7 is worth 7 ones, which is 7. And again, this is true. So we are going to color in that one. Next, it's saying that the 5 is worth 5,000. All right, well, there you go. You automatically know that's wrong. That's 50,000, like we just said. And then how do we say this is what they want to know? You would say this 50,000, so far it's good, 897, 897. Yes, so D is correct as well. So A, B, and D are correct on that one. All right, next, they're saying that we should check and see if these values are true. So what they did is they gave you an expression, and then they said what the value is, and you're supposed to say whether that's a true or a false statement, if that is worth, if this is going to come out to be 41, and if this is going to come out to be 27. So in order to do this, I'm going to do this off to the side and rewrite it. So how do we check this? Well, there's lots of different symbols and numbers. So you should be using, please excuse my dear Aunt Sally again. And let's see if this comes out to be true. So first you should do parentheses, which is right here, and that would be 14. And then you bring down everything else. So if you did this, it would be 55 minus 14. 5 minus 4 is 1, and 5 minus 1 is 4. And so is that a true statement of 41? Yes, it is. So this is a true statement. Next, I'm going to rewrite this one, be 25 plus, in parentheses, 14 minus 4, and then divide by 5, and it's saying it should be 27. So let's check. Again, please excuse my dear Aunt Sally. So the first thing is please, which is parentheses, so that would be 10. Bring everything else down that we did not use. And then any more parentheses? No. Any exponents? No. Any multiplication or division? Yes. So here was our division. So how many 5s go into 10? Counting by 5s to 10, you would get 2. And then plus 25. So that would be 27. So did it come out to be 27? Yes, it did. So this is another true statement. Okay, and then the next one, Tara bought 2 bottles of juice a day for 15 days. On the 16th day, she bought 7 bottles of juice. Write an expression to match these words. So let's first say what it said on the first thing. 2 bottles a day for 15 days. So we could say, okay, she bought 2 bottles a day for not just one day, but for 15. So to show it that she did that 15 times, you would say times 15. And then on the 16th day, she ended up doing something different. She bought 7. So how do you show that she did 7 more? You would just do plus 7 outside of that parenthesis. All right, next, select all the ways to express this. Mark all that apply. So it is very important to get more than one answer again. So for those of you who don't remember 10 to the second power just means you write it twice and then you times it. So also you can look at it as saying a 1 with 2 zeros. So you're still getting that same thing. 10 times 10 is still 100. So your answer should be equal to 100 or saying something of that nature. So is 20 the answer to this? No, it's not. How about 100? Yes, it is. So we did do that. They're saying in order to do this, you should be doing 10 plus 2. That is absolutely false. You should also do, they're saying you could do 10 times 2. Remember, you cannot do that. I told you that a million times. No. So you cannot do that. This is not true either. You should do 10 plus 10. Well, 10 plus 10 does not give you 100, so that is false too. Also, these don't give you 100 either, so that's not true. And then 10 times 10 is the same thing, and that is correct. It does give you 100. So therefore, the only 2 answers on this was B and F. So that is the end of the review. So next week, we will be talking about chapter 2, and we'll be going into chapter 2. So I will see you then. All right, bye.